All right, everybody, we are still working in Unit 4 and we're still on the first standard. This is our third video. And we took a moment to try another standard there on complex numbers because we wanted to be able to solve these with complex numbers. So we're going to be working again on solving quadratic equations, and some of our results today are going to have complex numbers in them. So if you need to go back and watch and review after this, watch the last video that was on, it was 441, and that was our fourth standard that kind of snuck in because we needed this little piece of it. Go back and watch that. But we're going to be solving using inverse operations today. So let's go ahead and get started on that. So we have to start by thinking, when can we use inverse operations? And we can't use inverse operations when our x's are separated, when our x's are in a lot of different places. Like, for example, when we had something in our first unit, like 3x plus 7 equals 4 times x minus 9 plus 3x. Okay, so if I had something like this, I needed to combine all of my x's into one spot before we could use the inverse operation table method, where we wrote all of the what happened to x here, and then we use this direction to solve it. So we have to have all of the x's, all of the variables, in one place. So they can't be spread out or it won't work. So that's really the key as to when we can do this. So let's look at the examples that I've got provided for us today. So here I see x is pretty much contained to right here, and it's being squared. And x is within this set of parentheses, but it's not in lots of different places. So these are two examples of when using the inverse operations is actually a really clean way to solve these problems. So I'm going to start by, again, making my table and asking what happened to x. So the very first thing that happened to x using the order of operations is that it was squared. And the second thing that happened is that we multiplied by 4. Then we subtracted 49, and the result was 0. So working back up, we would have to add 49, divide by 4, and then in order to solve this squared problem, we would have to square root. And when you square root, you get positive and negative. So I'm going to write that in the table so it reminds me that I'm going to get two different answers. So let's actually apply those to this 0. So if I add 49, I get 49. If I divide by 4, I get 49 over 4. Don't touch your calculator. I don't need to, because my next step is going to be to take the square root, and I want the positive or negative side of this. And so when I take the square root of a fraction, I take the square root of the numerator, which is 7, and I take the square root of the denominator, which is 2. So I didn't need a calculator to figure out what 49 divided by 4 was. I needed to be patient. So my two solutions for x are positive and negative 7/2, or positive and negative 3.5. Let's try this one using inverse operations. So once again, I'm going to make the table and talk about what happened to x. In this case, the first thing that happened to x was I subtracted 2. Then whatever that result is, we squared that quantity, and then we multiplied by 3. And in the end, the result was 12. So this one doesn't have to be equal to 0, like our zero product property had to be equal to 0. In this case, I can have it equal to anything as long as my x is contained in a single spot. So working in the reverse order, I'm going to divide by 3. I'm going to take the square root, and using the plus or minus, and then I'm going to add 2. So let's give this a try. So I take the 12 and I divide by 3, and I get 4. Then I take the 4 and I take the square root, and I have plus or minus 2. And then I'm going to add 2. But this is a unique situation because I'm going to have 2 plus 2, and I'm also going to have, notice this, I'm going to have negative 2 plus 2. So my two results are 4 and 0. 4 and 0. So I'm going to not always get this plus or minus where they're just the opposite of each other. My two results are 4 and 0. Do not put parentheses around here. It will indicate that we either have an interval, which we don't, or we've got an ordered pair, which we don't. So if you want to use anything, you may use brackets or don't use anything at all. All right, let's try two more examples. All right, so in these two examples, once again, I've got x contained in a single spot. Here's my x. It's not spread out. I don't have to combine like terms. It's just there. So for this, again, I'm going to make my table of what happened to x. The first thing that happened to x is we added 1. Then we squared it, multiplied it by 2, subtracted 9, and the result was negative 11. In the reverse, we will add 9, divide by 2, take the square root, don't forget your plus or minus, and then last we will subtract 1. So I will do the exact same things. I'm going to add 9, so a negative 11 plus 9 gives me a negative 2. If I divide that negative 2 by a positive 2, I get a negative 1. If I take the square root, positive and negative, of negative 1, I get plus or minus I. We learned that in the last video, that the square root of negative 1 is I. And then I'm going to subtract 1. Well, unlike the last one where I had a real number that I was adding or subtracting in the very last step, in this case I have a complex number that I'm adding or subtracting from. So there's not a lot of different ways to do that. You can't really combine these together. So I can write my answer in a couple different ways. I can write it as plus or minus I minus 1. Or if that makes you uncomfortable, you can write it as I minus 1 and negative I minus 1 and just keep them separate. So you have this way or the combined way, well, I guess it's the separated way of writing them as two different answers. But it doesn't change the minus 1. That was always going to be subtracted. What changes is the I, because that's when you took the square root. All right, we've got one more to try together here. So again, making your list of what happened to x is that we subtracted 2, we squared it, and the result was a negative 8. So working in the reverse order, I have to square this, or square root it, excuse me. So I'm going to take plus or minus the square root, and then I'm going to add 2. So when you take the square root, plus or minus of negative 8, I'm going to get plus or minus, let's write this over here, plus or minus 2I root 2. And that comes from reducing the radical, but also removing the negative, and it comes out in the form of an I. The last thing I'm going to do is take this very complex looking thing and I'm going to add 2. I'm not adding the 2 to the radical, which is the underneath. I'm not adding the 2 to the out front. This itself, I'm adding 2. I'm adding 2 to that quantity. Way too many 2's in my sentence there. So your results are plus or minus 2I root 2 plus 2. You may separate that like this. 2I root 2 plus 2, or negative 2I root 2 plus 2. So you can have it together or you can separate them. All right, great job. So I've got these last two examples for you to try on the Try These worksheet. Make sure you're trying them on the correct grid so we can keep ourselves organized. That's video 413, and you can fill in these two and make sure you go to Schoology and check with everybody else to see if they're getting the same things you are.